Hi guys, let's just wait 2 more minutes, then we'll start off. Okay, let others join. If anyone left, let them join. We'll start in 2 more minutes. Okay, guys, so we'll start with the presentation session first. Then, as yesterday we did, after the presentation session, we will start off today's session. Okay, so Isha, are you there? You are left with the presentation. Yesterday you were supposed to present, but time didn't commit it. So, based on that, you can present today. Are you there?
Yes, ma'am. Can I present somebody else after somebody else?
Okay, you don't want to go first. Okay, not mission. Okay, so who wants to present? Just let me know.
Ma'am, shall I?
May I know your name, please?
Shrija, ma'am.
Shrija. Just a minute. Shrija. Yeah, Shrija.
Yeah. So,
Okay.
Ma'am, after Shrija, can I present?
Sorry,
Ma'am, after Shrija, can I present Ayushi?
Ayushi. Okay.
Ma'am, can I present? I asked yesterday.
Yeah, Chetan. Okay. You can go after Ayushi.
So,
Isha,
Ma'am, I'm
do you want to go after Chetan?
Ma'am, okay.
Sorry.
Okay, ma'am.
ma'am after her.
After Isha, I will
Okay.
present, ma'am.
After Isha, who wants to present? Let me know your name.
Akash, ma'am, Akash.
Akash. Okay, Akash.
Ma'am after him I'll do. Manthan.
Okay. And after Akash, who wants to go? Fine. Okay,
Manthan.
fine. Okay. So we'll keep it like that. Yeah, got it. Fine. Okay. So accordingly, Shrija will go first, then Ayushi, then Chetan, then Isha, then Akash, then Manthan. Fine? Clear?
After Manthan, can I present it, ma'am?
Uh, okay. Ashifa, right?
Yes, ma'am. Yes, ma'am.
Okay, Ashifa. Just a minute. Like, see, we'll go according to time, right? If after Manthan there is time, you can definitely present. If not, you can go to like on any other day, like maybe Monday. Fine?
Okay, ma'am. Fine.
Okay. So you all have submitted the project, right?
Yes, ma'am.
In the mail you have already submitted the project, right? Everyone?
Yes, ma'am.
Okay, great,
yes,
great.
ma'am.
Okay, fine. Okay, then Shrija, you can just present it now.
Yes, ma'am. I'm presenting this. Is it visible now? Like I'm sharing it already.
You Yeah, you are sharing it, but your voice is breaking somewhat. Is it happening for everyone, or my network issue is having some network issue? Others, can you please confirm about it?
Am I audible?
it's clear, ma'am.
Yeah, it's
Ma'am, her
now it
voice
is
is
fine,
audible.
Shrija. Yeah, now it
Yeah.
is audible for me as well. Okay, great. You can
Okay,
go ahead,
ma'am.
Shrija.
Yeah, ma'am. Okay. Good evening, everyone. I'm Shrija. And for the week one project, I have taken the Olympic medal count by country. The objective is simple, that is to analyze the Olympic Games data set. I have taken the source from the Kaggle, which is 120 years. It gives 120 years of Olympic history. And it has two CSV files, that is athletes event and NOC regions. So We can, with this analysis, we can help, like, we can measure the long-term performance and identify the strength and weakness of particular country or sports. And also the government can analyze which sport needs more funding and infrastructure. So I've started the uh, I've started the project first from importing the libraries, and then I have loaded the CSV files using pandas. Then I've checked the rows and columns with the help of dot shape method. And these are the number of rows and columns. Then to check the column names, I use the columns and to list. I changed it to list form. So it will be easy for me to read. Next, I check the year, like from which year to which year the data set is from. So it is from 1896 to 2016. Then I've checked the type of season that is involved in the Olympic, that is summer and winter. Then 3 medals. And here we have 66 unique sports in the data set. Next, with the dot head method, I've got the first 5 entries of this data set of athlete. Okay. So to shorten and to make my analysis more precise, I have first considered to take only the Summer Olympics. So I have reduced the dataset size only for the Summer Olympics. And then in the Summer Olympics, the data is actually more larger than winter ones. So winter ones I'll compare later. So first I've taken only the summer one. And in some of the older Olympic games, they had included art competitions. But I wanted only to analyze the real sports that are played now. So I have removed the art competitions. Later, I have counted the medals for each country. Like, yeah, I've counted the medals by removing, like, for every team, there are some amount of members. Like, for example, I've taken the football team, okay? So football team has 22 players. So in the data set, for each member, a gold is included. So to remove that, I've taken this, like I've counted the 22 players as one. Like a team sport has won only the one gold. So the country has won one gold. So that's how I've counted here. And after removing the duplicates, these are the number of medals that I've left with. Next, I have merged the NOC regions, NOC and the region, because NOC were the markings of the country given. So I've changed it like into the actual name of the countries. So it will be easier for us to analyze. Then later have counted the medals by country, like each country or like over the years or over the decades, how many medals they have won. So I got this data, like top 10 countries. Then to represent it more in the bar, I have represented this data in the bar graph form. Okay, so here we can see the number of medals and the country's name in the x-axis. From this, we inferred that the USA has won the most of the medals in the over the decades. Excuse me.
I guess someone has switched on his or her mic. You don't worry, you just go ahead.
Yeah, okay.
Yeah, guys, don't do this like this
So from
because
this,
she is presenting, right? So don't switch on your mic in between the presentation, right? So it will just create impact because she just stopped right when she was presenting. So don't just switch on your mic as of now when she like anybody is presenting. Okay. So Shrija, you can continue.
okay, ma'am. Yeah. So yeah, in this bar graph, I inferred that the first top 10 countries, according to the medal count, is as follows. So USA comes in the first. Then I went with the like how many medals were given over the years, and we see that the graph goes on increasing. So medals have been increasing over the years as new sports were included and everything. Then we'll go with the types of sports. Like for each sports, how many medals were given. In that, athletes come the first and then goes on with swimming, wrestling, gymnastic, and so on. After that, for a particular year, which country has won how many medals? That's what I've checked here. For example, in the 1896, Australia won 3 medals, then Austria 5, so on. Then I've selected some
Shrija, your voice
6
is breaking.
countries.
Can you
Okay,
just
now,
explain the
ma'am?
last? Now it is fine. Can you just explain the last part once again? The last plot, maybe?
Okay, ma'am. Okay.
Yeah.
Yeah. So, like, uh, counting the medals here, like in a year, the country, how many medals it has won. So I have taken maybe Australia won the 3 medals, Austria 5 medals, and so on. Then I have selected the 6 countries to check like the count of the medal trends it has over the years. So again, this is a um yeah. So yeah, this is the graph, and here again I can see that in over the years, the Russia has more. In the 1980, it had won more medals. And we can just compare the different countries, like how each year it has performed and how the graph has went and come by. Later, I've used the Seaborn library to make the heat map of the Olympic medals. I've also printed the number of medals on the each tile so that we can easily check how the trends are. So again, here in this in this heat map, you can see that the most medals are won by Russia in the year 1980. But if you check the overall medals, the USA has won the more medals, that is 230. So in the overall number of count also, the USA comes first. And next I went with, and next I've divided the medals into bronze, gold and silver. So again, here I've taken the same year, 1896. In that, we earlier we saw only the number of medals. Now I've divided into the gold, silver, and bronze. So here we can see that Australia won 2 gold, and 2 bronze, 2 gold, 1 silver. So here I've divided the number of medals. I have taken a single year, any year, how many medals. So here
So your voice is breaking again. Uh, like others also having the same, like other can hear Shrija properly.
Voice is breaking.
Yeah, Shrija, your voice is breaking. Can you try and reconnect? We can just wait for you for 2 minutes. You can just reconnect because I'm unable to hear you at all.
Okay, ma'am, just give me 2 minutes.
Okay, okay.
And can you please explain what happened yesterday, as I was
Reconnect,
not able to
reconnect.
join yesterday?
Yes, who is saying?
Yes,
Pranay, yeah, you are telling something. Please tell.
yes, ma'am. I was saying that I was not able to join the session yesterday. So please, can you tell us in brief that what happened yesterday?
Yesterday, nothing. I have just told like we have started off with a project. Started like in session itself, we have started off with an EDA project. Just gone ahead with the details about it, like how to start off, what are the like data wrangling process. We have gone ahead. This all like we have discussed on.
Okay, ma'am.
Okay.
Yes, ma'am.
Excuse me, ma'am.
Uh, yeah.
I'm Hasni. Actually, I'm new to this training part, ma'am. Can I know how this training goes on?
Sorry, I didn't get you.
I am new to this training, ma'am. Yesterday was the first day
Okay,
for me.
okay.
So I wanted to know what's the training part, how it will be going, ma'am.
Like this is 6 week internship basically. So according to every week, there is certain theoretical part and also the hand-on practice that we do in the session itself, based on some of the programs. Sometimes based like yesterday you have seen, right? We have worked on a specific program. We have like downloaded the data set and started working on that. So similarly, we try to work based on the weekends, like the based on the weekdays, and on the weekends you are being given with the project that you have to submit by Monday is the deadline, and based on that on Monday itself, and the accordingly you have to present the project that has been given. Okay, clear, Hasini?
Yes, ma'am. But where
Ma'am,
we will find the projects, ma'am? Like our own we
that
should
will
take.
be that will be given to you in your WhatsApp group. And as of now, since the presentation is going, any of the query and the thing we will be discussing at the end of the session. We will keep a 10-15 minutes window open. There we will be discussing everything.
Okay, okay,
ma'am,
ma'am. Thank you, ma'am.
ma'am,
Because the presentation is going, Shrija is also waiting, right? So we'll
ma'am,
discuss everything after the end of the session. Yeah.
ma'am, ma'am, I'm new to this training session. What's going on? Can you explain, please?
What?
I am new to this training session.
Yeah, that's
Please,
what I told, right? I told that, right? You just wait, you just let the session go. After the session, whatever be your doubts, we will be telling. So, as of now, there is a presentation session going. After that, we will jump off to the original
okay,
session
ma'am. Okay,
that
ma'am. Thank
where we will be discussing about the stuff. Okay, there you will be getting the details, and after session, whatever be the query, I will address. Fine.
you. Okay, ma'am. Thank you.
Okay, okay. Now please let Srija go ahead with the presentation. Srija, you have joined, right? You just go ahead with the
Yes,
presentation
ma'am.
then. Yeah,
Yeah. My voice is audible.
yeah, it is far better. You can go, please.
Okay, ma'am. Yeah, so I was here. I was talking about the different medals that we give in the Olympics, that is gold, bronze, and silver. And to represent that, I have done this bar graph. We have stacked the gold, silver, and bronze medals likewise have shown. And here also the same trend which we have seen, that is USA, UK, and China, as we had seen earlier. The only difference is that now the medals have been differentiated. So here you can check like how many golds a country has won, how many silver a country has won. So likewise. Next, I have analyzed the Winter Olympics. In this, I have done the similar analysis as I've done in the summer. I've checked the first five entries and then again the bar graph of the top 10 countries. But here, in the first place comes the Germany, then Russia and Norway. Then I have again selected the four countries here, that is Norway, Russia, US, and China. And these are the trends. So conclusion, so far we can see that the summer has more sports and winter, even though it has smaller one, but the competition is intense. And in the summer, we can see that USA, China, Russia, they dominate. And in the winter, the Norway, Canada, Germany, they dominate a lot. And thank you so much. This is the analysis I've done so far, and I think I'll do more as I learn. Thank you, ma'am. Thank you, everyone, for your patience.
Okay, Srija. So next is Ayush. So you can present your screen and present your project.
Mm. Ma'am, is my screen visible?
Yeah, it is visible. You can start.
Okay. Good evening, ma'am. Good evening, everyone. I have made my project on credit card fraud detection. where the main objective of this project is to detect fraudulent credit card transaction accurately we're using machine learning technique. Since fraudulent cases are extremely rare compared to normal transaction, so the data set was highly imbalanced, and my project aims that analyze the transaction pattern in fraud versus non-fraudulent cases. It handles the uh, class imbalance to ensure the frauds are not overlooked and built. Um and the application, like you can see the problem statement, the credit card for fraud is a serious issue for the bank and customer, so it leads to a financial losses and reduce people's trust. So the application of this project was in banking sector and financial institution, where it detect the suspicious credit card transaction in real time, so it prevent the monetary losses and protect the customer trust. And in many other sectors like e-commerce platform, payment gateways like Razorpay, Paytms, or insurance companies. Now, moving forward to the code section. Uh, in the starting, I have imported all the required libraries which are needed in my project. The NumPy for the numerical operation, pandas for handling and manipulation of the CSV file, matplot for the plotting the graphs, and seaborn for the advanced visualizations. And I have used matplot I have used grid spec for the layout control multiple subplots. Then I have loaded the data set like this in this, and then I have used the head for the watching seeing the all the first rows of the data set, where my data set I have took the this from the Kaggle, the credit card fraud detection, where it has 2080 approx 80 2 lakhs 80 records, and in which the fraud cases were around 500. It was less than 2%, and the time period. Total it has 31 columns, where it has time, V1 to V28, and amount and class. This was not clearly visible because due to confidentiality, this data was given in PCA, Principal Component Analysis, which I have used directly. Then moving forward, I have used information so that I can see what are the columns, is there any null value or it counts, and the data types, what are the data types present in my project. Like I can see all the float type for data, and in the last the class session, which has int type of data. Since my data set doesn't have any null value, but it was a EDA project, so it is important to show the all these steps. So I have also done this, that my data set has any null value or not. So you all can see that it has 0. Then I have used the describe function, describe, so that it is used for the give the all the statistical summary, like what are the mean and count and standard deviation, a minimum and maximum of all the rows and columns. Then I have analyze the data. Here I have split the data into fraud data, and in this valid data, all the non-fraudulent cases were there. Then I have find the outliers, where it tells the ratio of fraud to non-fraud data. Then it counts the all, like I said, it counts the all fraud data, and these are the number of non-fraud data are present. Then I have explored the transaction pattern. This is then I in this I have also split the data into fraudulent and non-fraudulent. Here then I have done in the splitting in split, I have done what are the fraud cases. Then I have find the describe, like for fraud cases, what are the count and mean and deviations. And then For the non-fraudulent cases, what are the describe like what are the count, how many datas are there, and what is the mean of that, and standard deviation for that. Then I have plot the correlation matrix heat map to show what are like how many datas are correlated to each other. Like the white color represents that it is correlated to itself only, like this in rows and in x-axis and y-axis it is the whole data set from class to time. Um, then I have I prepared a data set for training. I have used a random forest for this training the model. Here I have used 80% of data for test training and 20% data for testing. You can see. Then I have evaluated the then I have evaluated my model. I have used accuracy, precision, recall, and F1 scores because since the data was because of confidentiality, it wasn't given an PCA score also. So it is more than accuracy. This was needed so that it will be trained properly. Here I've used also confusion matrix plot where these were the cases. Here we can see what are the insights. The data set is highly imbalanced with fraudulent transactions, making up less than 0.2% of the records, where most fraudulent transactions were involved in small amounts compared to genuine ones. And the fraudulent transaction do not follow regular patterns daily. Like the fraudulent cases were very less because that's why we have to see the at what time was there, at what time the cases the amount was transacted and how much amount was transacted. So that was all needed. And like I told, from V1 to V28 the PCA visualization shows that a PCA was used, where visualization shows the fraudulent and non-fraudulent transactions from somewhat distinct clusters. And these patterns highlight that while fraud detection is difficult, there are clear differences that machine learning models can use to distinguish fraud from genuine transactions. Thank you, ma'am. Now I'm done.
Okay, Ayushi. Next, who is this?
Chetan, ma'am.
Okay, Chetan. Okay, Chetan, you can press in the screen and start your presentation.
Okay.
Good evening, ma'am and
And
everyone.
Ayushi, just one more thing. You have like taken only one data set, right?
Yes, ma'am.
Ma'am, is it,
Okay, okay, got it. Yeah,
ma'am, is it visible?
yeah, it is visible.
Okay, ma'am. Good evening. So I worked on the project called credit card fraud detection trends. And in this project, I analyzed the Kaggle credit card fraud dataset to study the patterns in fraud and non-fraud transactions. Okay, and then
Good evening, ma'am and
since the fraud is a
everyone.
critical
Going to
challenge for
present you the
financial
project
institution,
cyber
this
attacks
analysis
and
helps in
cyber.
identifying key difference between fraud and non-fraud transactions. So let's move to the
So
code
I'm
section.
Tanisha
Okay.
Shrivastava and I've conducted this analysis. Before we
Hello.
dive into the data,
Chetan,
I
just a
want to
minute.
tell
Someone is
you
saying.
why I chose
Okay.
this
Isha,
topic.
you are telling something or anything you are telling? I'm not understanding
Ma'am,
what you. Yeah,
sorry, ma'am.
yeah, tell.
Ma'am, no, ma'am, nothing, nothing.
Then why you people just switch on your mic in between? He was giving the presentation, right? You people need to understand. Every time, in case of Shrija, also some person has just switched on their mic. Please don't do it like that. It creates disturbance, right? Chetan, you can continue.
Okay. So here I started with importing the necessary libraries like pandas, matplotlib, and seaborn. Basically, pandas is for data manipulation, and both matplotlib and seaborn for data visualization. Okay. Then in next I loaded the Kaggle dataset, which contains about around 284,807 transactions. Out of this, only 492 are fraud, which means fraud cases are less than 0.2%. So I display
Chetan, your mic is off. I am unable to hear you.
sorry, ma'am. I just saw now. Sorry. Okay, I will
Yeah,
repeat. Sorry.
yeah, you just, yeah, not totally. After this, scroll down,
Here,
scroll down. Yeah, you
this
don't have
one.
to go ahead with missing values. After missing values, you try, like you start off.
Okay. Okay. Here, I separated fraud and non-fraud transactions and plotted their transaction amount. From the histogram, we can see that fraud transactions generally have lower amounts compared to normal transaction. Here, this shows the frauds often test with smaller amount of detections. And in the next, again, I have plotted a fraud versus non-fraud distribution using pie chart. Around 99.83% of the transactions are genuine, while only 0.17% are fraud. This imbalance is major challenge in fraud detection because a simple model predicting everything as non-fraud would still have high accuracy. So in next I have plotted this PCA plot, scatter plot for the same data. Since features are anonymized using PCA, principal component analysis, I have plotted a scatter plot using V1 and V2 components. Here, the red dots represents fraud transactions and blue dots represents non-fraud transactions. We can observe that fraud transactions often form small clusters away from the majority of non-fraud points. So next I have plotted the correlations heat map of the features. From this we can see that some features such as V17, V14 and V12 and V10 have strong correlation with the fraud detection. So here this red line represents that the chance of fraud is high, and this here where the V3 meets and in this V2 column we can see 0.53. This represents there is the fraud chance is low, and this zero represents it doesn't make any this doesn't make any changes in the data set. So finally, this is the simplified plotting of the same heat map. This shows here V4 and V11, and yeah, V4 and V11 have higher fraud chance of fraud, and in the V14 and V17 we have less chances of fraud. So that's it, ma'am. Thank you.
Okay, you haven't included the conclusion part, like in the
Uh, like
Here itself you
text or
haven't
something.
included, right? Okay, not an issue. Okay.
Yes.
Yeah, in text format, I'm saying yes. Yes. Okay,
Okay, I
not an
can include
issue.
now.
Okay, not an issue. You have
Yes.
already submitted, not an issue, not a major thing. Henceforth, in any of the project, try and maintain that, right?
Sure, ma'am.
Okay, okay,
Thank you.
okay, okay. Isha, are you there? You want to present?
Yes, ma'am.
Yeah, you have to speak a bit up, okay? Because your voice is really low. I'm unable to hear you properly.
Okay, ma'am. Okay, ma'am. Is it visible now?
No, not visible.
First, I share my screen, ma'am. Is it visible my screen, ma'am?
Yes, it is visible now.
And now my audio is clear.
No, not audible. Your voice is really, really low. I am unable to hear you.
Ma'am, there's a network issue, that's why I think.
Okay, then you can just give for today. Let other go ahead. You can present in next session.
Okay, ma'am.
Because if I am unable to hear you, then what's the point, right?
Okay, ma'am. Okay. Ma'am,
Yeah.
it is not visible clearly, right?
Like visible or your voice. Previously it was
Voice
not
clear,
audible.
clear.
Yeah, yeah, now it is better. You can. You can present, not an issue.
Okay, okay. So can I start, ma'am?
Yeah, definitely. Go ahead.
Good evening, ma'am, and everyone. Today I'm going to presenting my project on cyber tech trends by sector. So my name is Isha Srivastav and I have conducted this analysis. So before we dive into the data, I want to tell you why I chose this project topic. So I chose this topic because cyber threats are increasing rapidly every year. Almost every sector, whether it's healthcare, finance, energy, education, or IT, is vulnerable. By analyzing the trends, we can gain insights into which sector are the most at risk, what kind of attacks are common, how organization can take preventive measures. So this provides us with the necessary context to analyze the data effectively. For this project, I've used the cyber incident.csv dataset from Kaggle, and the primary objective of my analysis to investigate and understand the trends by cyber attack across different industry sectors. To achieve this, I've utilized Python and the libraries like Pandas uh, and for Matplotlib and the Seaborn for visualization. So my first step was to import the necessary libraries uh, and load dataset. I import the pandas library as PD and loaded the cyber.incident.csv file into a data frame called df. To get a quick look at the data structure and content, I displayed the first few rows using df.head. As you can see here, the data set contains information such as incident ID, date, year, sector, subsector, country, region, attack vector, action, malware variant, records affected, and many more. Severity, source link nodes. Then, after loading the data, it's important to understand its dimensions. So, to understand the dimension and the available information, I check the shape of the data frame using df shape, which tells us the number of rows and columns. The data set contains 10 records and 15 attributes, 15 different attributes like internet ID, date, year, sector, and subsector, malware variant, source link. So I also examine the column named using df column to see all the variables available for analysis. So this confirms we have relevant information like sector, attack vector, severity, and record affected, which are key to over our objective. After that, uh, this is the frequency of cyber attacks by sector. This is the bar chart. It shows. So I calculate the number of incidents per sector and visualize the using a bar plot. This chart shows the frequency of cyber attacks by sector. As you can see, the mention here, finance and education sector appear to have the highest number, like this. Ma'am, is it true?
Yeah, yeah,
Ma'am,
tell.
is it? Yes.
Is it?
1 second, ma'am, 1 second. Uh, Now the finance and education are the highest uh, number of reported cyber incident in the dataset. This aligns with the initial understanding that sectors dealing with the sensitive data or having large user base are often prime targets. So to generate this plot, I use the value count function. I use the value count function uh, on the sector column to get the count, and then the use Seaborn bar plot function to create the visual representation. I also rotated the x-axis label for better readability. After that, next I want to see how the number of cyber attacks has changed over the year. I counted the incident for each year and plotted this trend using a line plot. This chart is titled Cyber Attacks Over Time. Looking at this plot, we can observe we can observe a steady increase in reported incidents from 2019 to 2021, and then it seems to level off or fluctuation in the number of attacks over the years. This gives us insight into the temporal patterns of cyber attacks within the data set. So for this, I use the value counts on this year column, and then I use Seaborn, sorry. Then I use Seaborn to import visualize the trend. After that, After that, understand the methods attacks use is crucial. I analyze the frequency of different attack vector types to the identify most common ones. This bar chart shows the top attack vectors, like this. So here we can see that based on our plot, phishing, ransomware, and web attacks, phishing, ransomware, and web attacks are the most prevalent attack vector in the dataset. This highlights the importance of defenses against these specific types of attacks. So I use the value counts again, this time on this attack vector column, and took the top 10. Then I use Seaborn bar plot to visualize these top vectors. After this, to understand the severity of attacks within different sector, I created a heat map. This heat map shows the heat map of cyber attacks by sector of severity. So this darker and the red color, the higher the number of incidents for that combination of sector and severity. You can see the intersection of finance and high severity shows a relatively high number of incidents. This allows us to identify which sector are experiencing the most severe attacks. To generate this, I use PD crosstab, PD crosstab to create a frequency table of sector and severity, and then use Seaborn's heat map function to visualize this table with annotations and a red color map. With this, so to show the proportion of cyber attacks across different sectors, I created a pie chart. Uh, this chart is titled Cyber Attacks Distribution by Sector. This pie chart provides a clear visual representation of which sector accounts for the largest share of incidents in this dataset. You can easily see the percentage of attacks attributed to each sector. For instance, the finance sector represents the largest portion to 20% of the total incidents. So to create this, I use value counts again on the sector column and then use the plot pie function directly on the result. I also added percentage to the slices and a shadow effect for visualization. After that, beyond just the numbers of instance, it's important to understand the impact in terms of records affected. So, sorry. I calculate the total number of records compromised in each sector and visualized by sector. So this chart reveals the sector that have experienced the largest data breaches in terms of the number of records affected. So the finance sector shows the highest number of affected records exceeding 1,20,000. This highlights where the most significant data loss has occurred. To generate this, I grouped the data frame by sector and then calculated the sum of the records affected for each group using dot sum function. I then sorted the result in ascending order and create a bar plot. After that, uh, after performing the exploratory data analysis and generating visualization, I saved the process data. This code cell saves the data frame to a new CSV file named clean cyberincidents.csv in the data process directory. The index is equal to false argument. Index is equal to false argument ensures that the data frame index is not written as a column in the CSV file. This file dataset can be used for further analysis or for building applications. And next, the conclusion of my project. The analysis revealed that the cyber attack impact various sectors with varying frequencies and severity. While some sectors experience a high number of incidents, others face an attack resulting in a greater of affected records of higher severity levels. So the distribution of attack vector also highlighted common method used by attackers, different industries. So overall, the dataset provide valuable insight into the landscape of cyber threats and their impact on different sectors. So uh, this is my overall analysis. So thank you, ma'am.
Okay, Isha. Next, Akash is there, right? You can share your screen and present.
Okay, ma'am.
And you don't have to explain the code, okay? You just go ahead and like for the plots, basically, you just show the plots and whatever be the insight that you have got, you just explain those. Right?
Ma'am,
Okay, ma'am. Can you hear me, ma'am?
Yeah, yeah.
Good evening, all. I am Akash, and today I will discuss about cyber attack trends by sector. The main objective is to identify, compare, and evaluate cyber attack trends. And I have got the dataset from a Kaggle Hub, which we can run directly in the Google Colab. And dataset is this. I have imported that dataset. The files in this dataset is Global Security Threats 2015 to 2024. And we have 3000 rows and 10 columns in this dataset. We can see various countries and years, attack types like phishing, ransomware, and target industries like education, retail, IT, telecommunications, etc., and financial losses in millions, number of affected users, attack source, and these are all the columns in this dataset. We can see here all columns in this dataset, and these columns say about country, year, attack type, target industry, security vulnerability type, defense mechanism use, and incident resolution time. Then we can see the information about this by using df.info, where we can see all null values and count of all these. There are no null values in this dataset, and all columns have 3000 values and having various data types such as objects and integers. Now we will take these numerical columns and categorical columns separately, and we will describe about these all are mathematical parameters of this dataset like count, mean, standard deviation, minimum, maximum value, and these are the quantiles of 25% quantile. These are used to plot the box plots. And now we will check for the missing values. There are no missing values in this dataset. And we will plot the box plot for outlier detection. We have plot the box plot for all the datasets, all the columns. Next, we will go for the univariate analysis. Here we will draw the R charts for all the columns. Firstly, we can see here number of incidents per year. Based on here, we have the count of incidents happened in cyber attacks. Next, we will have the target industry such as how many attacks has happened on every target industry like IT, bank sector, healthcare, and all these. Next, we will see about the attack type, which attack has happened, how many attacks has happened on each attack type, that is phishing, SQL injection, ransomware, etc. Now we'll see the proportion in pie chart. Here we have highest is that is 17.7 DDoS, and the lowest is man in the middle attack. This we will get from this pie chart, and I have written all these outcomes here, pie chart and bar chart outcomes. Then we will go for the distributions of distribution in the count of each year, how many attacks has happened in each year. This is financial loss distribution, and this is number of affected users distribution, and etc. Next, we will go for the bivariate analysis. This tells about the cyber attacks on which year and which target industry. We will see these colors indicate, this orange color indicates retail, green color indicates government sector, telecommunication, red color, and these all are indicated in this diagram. Then we will go for the cyber attacks by year and attack type. This is year and target industry, and we will go for the year and attack type. That is ransomware, phishing, malware, and all these. Next, we will go for attack type across industries. Which industry has how many attacks? Then that we will see in this bar chart. Next, we will go for the correlation analysis. That is by using heat maps from SNS Seaborn library. Here we can see all the correlation, and phishing is very much correlated with 2017. Now we will go for the analysis. These are, we are grouping the year and target industry and can find in the number of cyber attacks on which sector happening. Here we can see in 2015 the incident counts, that means cyber attack counts are 43, education sector 30, and here we have year-wise data and number of incidents happened in each target industry. And this is what we have got is first 5 columns and first 5 rows and last 5 rows here we can get. And next we will go for attack type, and value counts tells about the number of attack vectors. Here we can see attack type and the total number of attacks on that vector. Next, we will check for the year and incidents. On which year? Then we are going to plot these cyber attacks per sector by year by using this plot. Here we can see the highest attack on this education sector in 2018, and lowest is on 30, which means education sector also. This is also education sector. These are all outcomes of that diagram. Next, we can see the top attack vector per sector. In which sector many attacks has happened. This we will see the bar chart. Here we can see the banking has many cyber attacks, nearly 90, and the education has lowest attacks, nearly 75. And next we will go for on which year the top attack vector has been happened in which sector. And this is the diagram of that. Banking has the more attacks, nearly 95, and more phishing attacks are done on banking. And DDoS attacks have happened in education sector morely. Sorry, it is less. Top 10 attack vectors are here in this data set. DDoS is the top. DDoS and phishing has the top attack vectors. It's already completed. This is the correlation for year and every sector. We can see here many of these happened in 2018 on education sector. And this is my overall conclusion. Thank you, ma'am.
Okay, Akash. Next is Manthan, right? So you just present your screen and start explaining the presentation that you're having, the project actually. And as like Akash, you don't have to go in details about the code, but try to put in whatever be the insight you have got. Try to like explain those based on the plots that you have done.
Is my screen visible?
Yeah, it is visible.
Okay. Hi, I'm Manthan MY from Karnataka. My project is about import-export economic dataset. Here is the project summary. There are global trade analysis project offers a data-driven exploration of international import and export flows across countries. Here we can see what type of data I have used. Univariate analysis. There are trade values, trade direction, country and product data, and I have used bivariate analysis, like comparison between countries and countries, trade values, trade direction and products like that. And multivariate analysis, I have used Sankey data flow. For that I have used country, product, and trade direction. Trade direction, nothing but how whether it is export or import the country is doing. Here is the problem statement. Global trade flows are increasingly complex, dynamic, and sector specific, and this project aims to build a reproducible modular analytic pipeline that cleans, analyze, and visualize large scale import and export data across countries, products, and time periods. Uh, Here is a basic business objective to develop a scalable modular analytic pipeline that transfer raw international trade data into actionable insights. This project helps policymakers, economists, and business leaders to make data-driven decisions on trade strategies and supply chain optimization. I have taken the data from UN Comtrade website. Uh, Here we can see import essential libraries and load the dataset. In my dataset, there are 10,000 rows and 26 columns. And here data inspection is going on. In the head, we have seen five rows and 26 columns. Here we can see there are different columns like transaction ID, country, commodity, trade type, and quantity, unity, currency, etc. like that. Here there are no null values. Here we can see there are zero missing values and zero duplicate rows. Uh, in my third cell, I have cleansed the data and type corrections. Basic cleaning complete and ready for deeper exploration. Here we can see the univariate data analysis. Here we can see box plot and distribution of year. As many of you know, box plot represents the minimum, maximum, and first quartile, third quartile, and median value. Here we can see the first quartile is on 2013, and the third quartile will be in 2021. Like this, these values goes on. Here is a categorical insight what I have shown in univariate analysis. In this code, we can see here top countries by total trade value. Uh, the first place taken by Slovenia, and followed by China, Barbados, Gabon, Sudan, Hong Kong, Ghana, Wallis, and Costa Rica, India, like this. And the top commodities like plastic holds the first place here, and the pharmaceuticals, electronics, vehicles, oil, like this. Trade value is nothing but uh, a country a country's trade value can be determined by its import and export values. In this cell, we are going to talk about the monthly trade value trend. Here we can see in 2021 there is a all-time low due to COVID, and there are many specific reasons behind this trend. In this cell, we can see both import and export graph. Here, orange color shows the export values, and green color, um, orange color shows import values, and green color shows the export values. Here we can see 2021 is the all-time lowest import happened. Many countries tried to import the values, but there are some issues due to COVID. So countries don't, yeah. Here monthly trade values by country. There are top 10 countries. Here we can see from 2010 to 2024 how countries are performing its trades. Here monthly trade by direction. Direction is nothing but whether it is import or export duties. In this chart, we can see trade surplus and trade deficit. Trade surplus is nothing but a country which is having more value than it is importing is surplus, and deficit is nothing but a country is a country is importing more and exporting is less is nothing but deficit. And here we can see and here cumulative trade balance by country. Here, countries like Kuwait, Australia, and San Marino are the most balanced countries. These countries uh, export and import in the same way. They don't have any trade surplus or deficit. And countries like Russian Federation, Guyana, and Cuba, these countries export more to the world and import less from the world. And the countries like Philippines, Zimbabwe, and Korea, these countries import more and export products world less. And here are the top 10 product by total trade value. Plastic holds the first place, and pharmaceuticals, electronics, and vehicles. The list goes on. And here it is a here we can see a small summary of this project. In 2024, Hong Kong led trade with the total value of this amount, and the top product was plastic and contributing 10.55% of total trade. Finally, I have used multivariate analysis by using a new method called Sankey data flow. Here we can see the relation between the countries. Here countries involved like China and Germany, major exporter and especially to the machinery sector. India act as both recipient and secondary export, bridging flows between sectors. EU and USA final destination for high value sectors like electronics and pharmaceuticals. Here we can see. And the conclusion, this project successfully delivers modular and reproducible analytics pipelines that transfers raw international trade into strategic insights. Thank you.
Okay. Okay, Manthan. Just stop your screen sharing. Now just we will start with the session for today. So just a minute, let me just share my screen now. And guys, today I'm facing some network issue. So if anything happens, if you are unable to hear me or my screen is not visible to you, just let me know. Fine. Guys, anyone there?
Ma'am, can I present?
Yes, ma'am.
No, ma'am.
What no, ma'am?
Ma'am, can I present?
No. See, today we will be starting off with the session for today because our session needs to go on, right? So you can present on the next day, right?
Okay, ma'am.
Okay, my screen is visible to you?
No.
Okay,
No,
okay,
ma'am.
just a minute. Okay, just a minute. Now?
Not yet, ma'am.
Yes, ma'am.
It's visible now.
Yes, ma'am.
Visible. Okay, fine. So as discussed today, we will be going ahead and learning some of the like how we can plot such interactive plots that we will be learning. We are continuing with the yesterday's yesterday's data itself. That is the heart disease data that we have taken off. And see, there are some people, I guess, so for them, I'm just telling, like we have yesterday, what we did, we have just taken down the heart disease UCI data. You will get it in Kaggle. We have just imported it and done some of the pre-processing task. So now here, what we today we are basically doing, we are using Matplotlib. We're trying to learn how we can do the interactive plotting. Fine. We want to we want to make our plots more interactive and wants to make it more colorful and easy appealing. That's why we are using it. Fine. So let me just show you the data set, how it looks actually. So this is the data set. Is it is it visible, audible, everything, guys? My voice is audible?
Yes, ma'am. Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am. Okay, okay, got it. Fine. So you can see my screen, right?
Yeah, ma'am.
Okay, fine. So this is the raw data set that actually we are having. So here the basically what these are the column names like that counts into ID, age, gender specifications, then the data set, CP, then this test BPS. So let me just say tell you specifically what it actually means. Okay, so let's just go deep dive into for 5 to minutes, 5 to 6 minutes, because there are some people who are new to this. So if I don't give a brief about it, they won't be able to understand. And this will be also a brief to you people so that you can easily connect with today's session. Fine. So for the age, we are having two kind of people like the age of the patients basically, because here we are considering about heart disease. So age
Excuse
sec
me, excuse me,
yeah.
ma'am. Sorry for interruption, ma'am.
Okay.
I can't see your screen.
Is it same for everyone?
It is visible, ma'am.
Ma'am, the Excel sheet
Yes,
is
Yes, ma'am,
ma'am.
it
It
visible.
is
is
visible,
visible.
ma'am.
Yes,
It is
yes.
visible,
I'm
ma'am. It is visible, ma'am.
okay, okay. Okay, I'm just presenting the Excel sheet. So whoever is not able to see, just reconnect. Okay, you
Okay, ma'am. I'm
just try and
connecting.
reconnect. Yes. So as I was telling, for the feature, first feature is the age, where the age of the patient has been mentioned. Next is the gender specification, that is the biological sex of the patient has been given, where it has been considered if the patient is male or female. So here we will be considering it like after pre-processing, we have considered male value and female value. In this format, we have considered so that it is easy for us to plot. Fine. And next, we have taken into consideration that CP, like the data set and the CP data set. It is basically whatever be the details we have put it through. And basically, we have just in the last session, we have just dropped off this column because that doesn't given any of the specific information up. CP is basically the chest pain type that we are having. So there are specific names that has been given to the types of the chest pain. And test BPs, it is the resting blood pressure. Okay, it is basically the resting blood pressure, how our blood pressure counts, what actually is it, how what actually it is that actually we get from test BPs. Then then is the cholesterol, that is the serum cholesterol number. FBS is the fasting glucose, blood glucose level. Okay, and then rest ECG, that is the resting ECG result of the patient. Then TAL CH, that is basically maximum heart rate that is achieved. Okay. Next is that EXANG, that is the exercise that included angina. Okay, so this contains according to the patient that has a chest pain. Angina is the chest pain basically that is happening during exercise. Okay, that is the range. Like if for what person it is having or not, this in that format we are getting the true and false value for this. Okay, then old pick is the like you are well acquired with the ECG pick, so it is like that only, like the steeper pick and all. The this column signifies that. And CA is the number of major vessels that we are getting in through, like major vessels that are colored by the fluoroscopy. Okay, and going ahead, we are having this THAL. THAL is the thalassemia test. THAL is the thalassemia test that we are getting. And this num is the target variable. And in yesterday's session, we have converted that to form a heart disease. We have rechanged it and formed a column that is named as heart disease. So guys who are new, the data set is clear to you, right?
Yes, ma'am.
Okay, fine.
Yes, ma'am.
So great. Okay. So we'll just go ahead and see like how we have gone ahead with the plotting purpose. Okay. Because henceforth, I want you in any of the EDA project that you are going through, basically most of the person, what you are doing, you are plotting the curve. That is very nice. But the thing is, we need the plots to be more interactive. We need to be it more interactive so that it is easier for people to understand, right? So try to incorporate this kind of plots in your future projects, right? So similarly, what it just we need to plotting purpose. So we just imported the libraries, loaded the data set. Now we are going ahead with the plotting part. So basically here we have gone ahead and see that is the presence of heart disease. The num column that we already had, this one. Yes, this one, this num, this is actually that is actually the like the target column that we are having. Apart from that, this 1 2 0, this actually signifies the range or the level of different heart disease. 0 that counts to be no heart disease at all, and often with 1 we are considering that heart disease is present. So in the yesterday session we have counted it off and taken into consideration and calculated with the different like alternate pre-processed data we have gone ahead with, where we have only concluded the value, like scaled the value between 0 and 1. Okay, so that either means that the value is present, that is 0 is present, that is 0 that signifies no heart disease, and 1 does signifies that disease is present. Fine. So I'm just going ahead and showing you this plots. Yes. So we'll just see how actually we are seeing through this plot and how we have created this. So this one is a like basic scattered plot, but we have tried to make it colorful and also included based on the chest pain type. That is the CA. That was there in our data set. We have included that and we have tried to make a scattered plot out of this along with this based on this chest pain type. Okay, clear? So we'll move into the code. What we have done in the code that we will be like now we will be figuring out. Any question to ask or anything like that? Guys,
No, ma'am.
everyone clear up to now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Clear, right? Okay, okay, fine, got it. So what we are doing up here, we are doing like we are like going ahead and doing creating a variable. The name of the variable we have kept use df underscore clean cp, df underscore clean cp with value count and n large 4 with index. Okay, so separately what we will be seeing what we are doing. We have taken the column for this part. I am just highlighting up here df underscore clean, that is cp we are doing. Okay, here what we are actually doing, we are taking into consideration the column, the name of the column is cp. Okay, that we are doing up here from the data frame. The name of the data that is CP. Actually, data frame is DF. Then we have taken the we have just copied the column and we have copied the data frame and created and stored it in another variable named df underscore clean. Fine, clear? Up to this is clear, everyone?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, fine. Then dot values, dot value count. This part, what actually it is doing, it counts how many rows are there for each distinct chest pane type. Like we can think of, suppose there are, let me see what are what are there here. Chest pain types, okay. Asymptomatic, non-anginal is there, then anginal is there, typical angina is there. Okay, so what it does, dot value counts, it actually counts how many rows are there for each distinct data types, like like each distinct type of the chest pain. Suppose for typical angina, how many columns are there, sorry, how many rows are there under CP column, that they are counting of. Clear? Okay, clear?
Yes, ma'am.
Okay.
Yes, ma'am.
And dot largest, we can there are like from the counted list, like here dot value counts, where there we are counting the list, right? So we are only keeping only the largest four values, like the four most frequent values that we are getting, or the four most common values that we are like we are having, that we are counting. Because we what here we are doing, we are specifying age versus cholesterol for the top four chest pain types. Clear? So that's why we are taking into consideration like top four values, like the top four frequent values that we are getting, that we are considering. And dot index is like it is taking just the name or the labels of the top four values. Like this index value is like the small list, like this actually creating the list, and it result in the index type. Like here, this index type it is creating, for that we are doing this index. Okay. Then actually how we are just plotting it down, we are plotting it like we are using PLT figure, like we want to recreate the, like understand the shape and size. Okay. And this what top link, display top link, what it is done, it is saving the index, whatever with the index we are putting it, it is saving it. And also we are getting to display it, whatever display option we are getting, like here it is being displayed. So this is actually displaying in the top league version. Clear? Next, in this part, what we are seeing and doing here, we are actually plotting it down. We are using matplotlib here. So the lines are creating for the new plot, like is the size creating, because we are putting it under a canvas, right? So we have to check for the canvas size. So we have taken 15 cross 6, like 15 into 6, like 15 inch wide, 15 the wide, this way, like the horizontal part it is covering up, and 6 is the like taller or the height basically. Understood? So this is how we are doing it. And next we are using SNS plot, like the like scalar plot, like the seaborn plot that we are getting, that is scattered plot we are trying and putting it. SNS is the seaborn and scattered plot is the plot that we are want to plot it down. So this is how we are plotting, and here you can easily understand we are putting the title. This title has been put like age versus cholesterol. Then X plot, like for X axis, along X axis, what value we are taking, that we are getting it here. And then Y label value, like here cholesterol we are putting along Y axis, that we are taking into consideration. And then the title of the project that we are going into, like going and seeing it out. Like title means here for this part, what is the title we are considering, what is the anchor that we are getting, and where we are putting this index, that we are locating, that is upper left, and now we are showing it up. Okay, so here we are getting it through like how widely it is distributed, like for this four four types of chest pain, that is typical angina, asymptomatic, non-anginal, and atypical angina. So these are the most top four common chest pain that is seen among the patient. Okay, so so here abruptly, if you can see, like just by seeing the glance of the eyes, you can see this here itself. In this range, there are people, this orange color is more widely varied. That is asymptomatic is more widely varied up. And people having this range range of chest pain is about 50 to 60 in this range. In this age, it is more. And also people are like 40 to 50 or 30 to 40, there are people having this issues up, but in the range 50 to 60, the like the symptoms or the symptomatic chest pain criterias are more. Okay, this is the insight that we can on from 70, the patient number of patient is less. Okay, that we also can conclude from this. So clear up to this, clear guys? Any question, any issues?
No, ma'am.
Oh, ma'am.
Okay, okay, got it, fine. So this plot is clear to you, right?
Yes, ma'am.
Yes, ma'am.
Okay, so moving on, we are trying to plot. See, here what we are doing, we are moving on, but we are not getting, like, based on the plots, we are not getting to see what plot it is. That's why we have created a separate index up here, right? So here also we have created a separate index, but based on the plots, we are seeing like what the gender of the person, what is the cholesterol level of the person, what is the age of the person. Clear? So this is what I was talking about, interactive. This is actually more interactive, you can think it of like that. Okay, so for that we are importing plotty.express as px. Okay, so what actually is plotty express library? It is a quick way or quick interactive, like quick action way, we can see, that makes the plots more interactive. Okay, so henceforth, when you'll be going ahead with any of the ETA project or in detail of the project, try to use this. Okay, so that it will make your project more interactive, more appealing. So suppose if I am not having any idea about what project I am working on, or you have submitted this project, suppose, just by looking at the plots, if I don't see this lines also, based on this, just a click I am putting, like just scrolling it down and putting it like putting the cursor up in the points, we are getting like red dots. What is the type? It is a female. What is the cholesterol of this specific female? What is the age of this specific like this specific female patient, right? Even for blue also I am getting, it is male. Then what is the cholesterol level? It is 458. The age is 58. Okay, so this is how we are creating. So here we are doing a scattered plot itself. So you seen the difference, how to make it more interactive? It is clear.
Yes, ma'am. Yes, ma'am.
Have plotted cholesterol against age. Here also we have done the same, but here we have also concluded the gender of the person. Right. So similarly, we have just included, imported the Plotty Express library, okay, as PX. So Plotty Express dot scattered, we can write it as Plotty Express, like plot PX dot scattered also. Here we have done this. See here, because we want to take into count the scattered plot, right? So px dot scattered, we have write it in this format. Else have to write it plotty dot express. All of this stuff we need to do. So we have imported it as px. So we have written it as px dot scattered, because here we are plotting a scattered plot. Okay. So what we are actually doing, we are making with this, we are making a scattered plot. X, we have considered the cholesterol level. Y, we have considered the age. And for this colors, this dot colors, this we have actually considered the gender of the person, gender of the patient. And here, as you can see, height and width of the campus into consideration. Like width, actually basically considering the pixels, like 1000 pixels we have considered up here, and 500 pixels we have considered up here. So bigger the width we will be getting taking, bigger stretch it will give. Okay, so the stretch is in this format, like in horizontal way the stretch it will give. Okay, then the normal, the layout we have created, the title we have fixed, and we have just plotted it using pig.plot. Sorry, pig.show. Oh, this one is clear?
Excuse me, ma'am.
Yes, ma'am.
Guys, yeah.
Can we add one more access to the scatter plot, like one more feature?
See, like basically, if we add one more features, it will be very messy, right? And we try to put in 2D figure itself, right? 2D plots we try to put in. So, I don't want to make it more like, even you also, when you will be working accordingly and you will be presenting it to any of your like clients or stakeholder, he or she should understand, right? So if needed, you can do a comparison plot, like this scattered plot you did, and in the same figure you do another scattered plot with another feature up. So that don't make it more or more, that will, like, as you know, more simple the things are, more intricate details we get from that, right? So try to work it in this format. Clear?
Okay, ma'am.
Okay, if needed, if you want to put any other extra feature, plot another, like side by side, plot another scattered plot using another feature. Here we have included the gender. There you can include something else, like what is there based on your choice or your what is there in your mind to plot on. You can do it like.
FBPS you can.
Sorry,
We can add
I missed out.
FBS there.
SBS.
FBS, fasting blood sugar, in
Okay,
case
okay.
of
Fasting blood sugar.
cholesterol.
Yes, yes. Yeah, definitely. Like you can take into look is either they are correlated also or not. That also you can check from that, right? So you can plot it accordingly. Okay. So or I just wanted to show how the interactive ways, like how interactive the charts can be. So I have used this. So based on your preference and on which data set you are working, you can plot. Fine. So next is the blocks plot that we have used up here. So here we have similarly included this plotty.offline we have like used that allows you to, like what it allows, basically it allows you to plot without the needing of any of the like internet connection or anything. If you're not having the internet connection also, it allows you to plot. So I wanted iPlot. So if I need it in, I can plot it inside the Jupyter notebook also. Okay. So I needed iPlot up here. So I used iPlot. Okay. I need to figure it, like for the figure purpose, I needed it. So I wanted it. I just gone ahead and do it. So I wanted to show you what are the specific other ways also to plot. It's not that only from fig.show we can showcase the plot. From iPlot also we can just plot, we can showcase or display the plot. Fine. So here what I'm doing, we are taking into consideration px.plot. Like the previous one, like we have used px.scattered. Here we have used px.plot. That tells like plot, it actually what it actually tells the plotty express to make the box plot. Right. Previously, we have taken into consideration scattered. Now here we have taken into consideration the box plot. Fine. Then, as usual, we have taken the labels, we have gone ahead with the title, and we have plot the value. Like plot the figure actually, whatever be the figure that we have gone on. See how interactive it is, how good it when you are box plot, you are only getting this value. But here you are getting what is the minimum value, what is the lower fence that you are getting. Even you are getting the quartile range. What is the quartile Q1 value, Q3 value also, median. This actually, this line signifies the median. What is the median value for the data I have concluded I am getting? For age, basically, we have considered up here. So what is the median I am getting? What is the max value based on the data that I have got on? And what is the upper boundary or the upper fence I have considered on? Clear? Guys.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, okay, fine. Okay. So any query, any question?
Ma'am, your voice is breaking in the middle, ma'am.
Now also it is breaking.
Yes,
No,
ma'am.
Everyone
it's not.
have,
Sometimes breaking.
okay, everyone having the same issue, right?
Yes,
Okay,
ma'am.
just a minute. Let me just stop screen sharing and reshare, and just let me just check my Wi-Fi once. Just allow me 2 minutes. Guys, now is it clear? Better?
Yes, ma'am.
Yes, ma'am.
Now it will.
Okay. Everyone able to hear my voice? Is it clear to everyone? Every single person?
Yes, ma'am.
Yes, ma'am.
Okay, okay, fine. So I'm just okay. I have just switched off my mic. So like, is it visible? Screen is visible?
Yes, ma'am.
Okay. You people are able to, everyone is able to see the my screen, right?
Yes, ma'am.
Yes,
Okay,
ma'am.
okay, fine. Okay, and my voice is also clear?
Yes, ma'am.
Yes, ma'am.
Oh, okay, fine, fine. So here is the next plot that we have considered up. So we have what we have gone ahead. We have done here kind of like we have taken into consideration the old pic and for the like the size, like here you can see the bubbles. Here basically it is bubbles. The bubble slide we have considered. Here it is also a scattered plot. Okay, so here we are creating a new column. Okay, here basically we are creating a new column here. Pick clean, we want to create a new column that takes the old pick column into our data set. Okay, like from our data set, the old pick, that value it is actually taking into consideration. And clip lower 0, this actually replaces the negative value, because we do have certain like this one, clip lower equals to 0, that actually what it does, it like there are certain negative values that we are getting in through, so it just replaces the negative. Is no consideration based on the negative value. We don't want the negative value up here. So it is replacing the negative value with 0 and fill NA, that actually if there is any missing value or none value or null value we are getting, we are replacing it with the 0 value. So this actually is the pre-process, like the processing part that we did in the data set. Fine. So this actually we did. We have considered a new column, considered the old column, and done the operation clip lower equals to 0 and fill in a what remove the negative value from the old pick column and fill if there is any missing values or missing column or null value we are getting there, it is filling it with the 0 value. Okay, now we are just plotting the scattered plot. Along X, we have taken the cholesterol. Along Y, we have taken the age. The color we have taken along the CP, that is like the CP value we have taken into consideration up here. And size, old pick, the clean version of old pick that we have taken into consideration. And now we have plotted it. See how beautifully it has plotted. Similarly, we have plotted the scattered plot also, but it is more interactive, right? More cleaned, more easy to understand, right? So this is how we have plotted this. Okay, and also along like the chest paint type, actually we have considered it up here, and which color signifies what, that also we have considered up here. So basically in this section, this orange color level is more, right? So in case of in case of insights that we can draw, we can definitely tell this orange color, this is more asymptomatic level we are getting it all around based on this plot. Okay, so next, similar according to cholesterol versus age, we have plotted the similar way how we have to consider up here. So that has been plot based on cholesterol versus age. Okay, just a moment. Yes. So this we have taken into consideration and we have plotted off like this. Okay. Next, we have gone ahead with another plot. So what basically we are doing, we are taking into like separately we are plotting. So by this time, what we have done, we have plotted it accordingly. Previously we have plot according cholesterol versus age, and here also we have plotted cholesterol versus age, but we have taken into different consideration. Okay, and the layout also we have changed a bit. Okay, so then we are trying to plot it separately, like scattered plot versus age, but we want to plot it separately, right? So that we can take into consideration which type is more into consideration. Okay, so after this kind of plot, if we are plotting this, it is giving more insight, like by seeing we are considering previously that red, that is asymptomatic, is more, right? But there are certain cases we can't, but here separately when it is printing out, like when we are plotting it down, we can definitely understand this orange is very much, then considering we are having this green plot, apparently by seeing we can say, and then this blue, and then this purple one. So purple and blue are more of equal, but the height based on the age, this purple, this angina, typical angina is seen in more aged people, and like above 60 or above 50 people, this the plots are more dense. And in case of atypical angina, people in the lower group, like below 60, the plot is more dense. Clear, guys? Up to this it is clear?
Yes, ma'am.
Yes, ma'am.
Yes, yes,
Okay.
ma'am.
So then we are trying to put a bar plot, but here also you can see this is we have used that px itself. So here also it is like letting us know this what bar is putting for what purpose. So here it is giving the gender, the age, the cholesterol level, and also the old pig value. Okay, so typically we have printed it, like plotted it as a simply we have plot, we simply as simple we have plot for others, just like that. We have confined it the x variable, like the along x axis what we are putting, along what y axis what we are putting, and h over data what we are putting, like old pick we are basically putting, like this values we are putting, is this basically this actually putting, and the color specification is the gender of the person. Okay, clear? Then moving ahead with the next plot. So here also it is like over like bar plot, but it is generally using the group by plot. group by plot we are trying and using up here. So in case of this group by plot, we are the generating a data frame and trying to create it in this format. Like we are creating a function that is generate rating df. Okay, so what it does, it takes the data frame df as input and like a small machine you can think of, and putting it in that format and taking into consideration the group by format what we are taking, so that it is easily accessible and we can call it in this format. See here we have called it. We have called the function and plotted it accordingly. Okay, so here we have done it in this format. Separately, samely, we have gone ahead with this counts versus CP, like the type, the chest pain type. Here also we have taken into count and chest pain type, but here it was group by. But here also we have used group by, but taken into consideration the separate columns. Separate like columns have like specification. It has overhead. It was one upon the other. Right. So, but here we haven't taken like bar plot only we have plot, but we have taken into consideration one above other. But here the bars are separate, specific to specific color, like specific gender or the flat or the like what specification it has given based on that. Like the slope type. Basically the slope type. Understood? Understood?
Yes,
Yes,
ma'am.
ma'am. Mm.
Okay, got it. So here also we have taken into consideration the same, but the numbers we have taken into consideration. What is the count? What is the count of the numbers that we are getting? For atypical, the slope size, if the slope is down sloping, the slope is 3. Like the count is 3 28 for like up sloping the upward slope if we are getting, so we are getting 44. So for asymptomatic the inside we are getting flat, it is more, like flat we are getting the value as more, for then we are getting for upside, and then we are for down sloping is less in case of atypical. Then we are getting for the maximum we are getting for upslope. In non-anginal, the value is quite similar. One is 59 and one is 58. So upsloping is 58 and flat is 59, like down. Similarly, we have to plot in terms of percentage, the same thing. But see, the same plot we have done, but see how differently we have plotted. Previously, we have taken into count as consideration. Here we have taken percentage into considerations. So see, have you seen the levels by which we are checking into that? Like by which we are checking, like we are making the difference. How effective one plot can be just by changing some of the values, it can give the change, right? So understood this part?
Yes,
Ma'am.
ma'am.
Yes,
Okay,
ma'am.
fine.
Yes, ma'am.
Okay, got it, fine. So here we have taken into consideration like age versus cholesterol. The similar typical plot here we have gone ahead with the box plot, and also the bar, like the bar level plots we have also taken into consideration for all the chest pain types. Okay, so EDA project, this kind of plot should be there, right? Where we are considering like the title should be same, like we are considering age versus cholesterol only, but we are considering the different plots and at the same canvas or in the same structure in the under the same cell we are plotting, so that it is easily accessible and it is easy for others to understand how we are going in through, how we are checking, how the things are being made, right? So this kind of comparative plot should be there in any of your EDA analysis. Okay, then this kind, here we have gone ahead with a pie plot. How effectively here we have also considered that interactive method and also considered the percentage type, like what percentage, by what percentage and what. Next plot is like this. This black line, this actually get into consideration the overall trend. What is the overall trend that we are getting in through? Okay. So this similar kind of plot, we have already plot this, and just here we are getting the overall trend line basically to get in through how we are considering the data or the details. So similarly, this also, I'm not going into deep because this already we have discussed in details, right? So it's similarly we have plotted off like for different genders and accordingly for the same age versus cholesterol. I just wanted to show you the similar plot. How can we show it in different manner, in different format, in how in different way how we can present so that to us, how it is more convenient for us to understand, and even for when you will be seen by any of the person who have no proper idea about it, how they can relate with it, how they can understand this. So for this only we are like plotting it down. Okay. Next, this one, the similar one we already did. Here we have just taken the background as black for more intense view. Then this typical one, like the column plot or the bar plot, you can say. Similar one, like that was separate, the bar was separate, and here the bar has been stacked up altogether. So so that we can see the stacked up profile of the same along the same criteria and in what data, what number or what count. Okay. So here is a specific, you can see, think it of as a heat map that gives a clear cut idea about how the data are looking, we can and we have considered chest pain along the thalassemia, like based on thalassemia, how it is, how chest pain are more convenient or how it is been seen. Okay. And this is a gender specific plot that we are getting. And this type of this comparative type of data I was saying it, so this type of data should be there in any of your EDA analysis. Okay. This type of data where you can do the comparison, one by one comparison. Okay. And this is the peer plot. This has been done based on all of the three criteria that has been taken, and this kind of plots, try to include this kind of plots in your EDAs. Okay. Clear, guys? Up to this, everything is clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, okay, great. So hope you understood how we are plotting this interactive charts, how we are doing it in the form that it becomes more interactive. Okay. So I guess tomorrow, by tomorrow, you will be getting this week project. So as I guess you all know the drill, except the new people. For them, I will be explaining. But those who already know the drill, so you have to do the project, you have to submit it accordingly. And if you have been given, I am saying it repeated times, right? If it is a EDA based project is given, just do the EDA analysis. Don't just go ahead and plot 2 to 3 plots. Try and go ahead and plot at least 14, 15 plots, different type of plots. Try to plot it down. Okay. And try to make it more interactive as I shown you in today's session, right? So clear up to this, it is clear, guys?
Yes, ma'am.
Okay, great. Everyone clear, right?
Yes,
Ma'am,
ma'am.
can
Yes,
you share the file in the chat?
Sorry?
Can you share
ma'am.
that
What
file
the
in the chat?
What I can share?
That EDA file.
Sorry, that I can't share. See, I will try from my end. If like if it is allowed, I will try and share it. Okay. Else not, I have already shown you. If you want, you can just take a look. Again, I am just scrolling it down from the start. You can just take a look, like what plots I have considered up here.
Ma'am, you didn't share the screen, ma'am.
Okay, I didn't share it. Okay. Okay. Sorry, sorry. Actually, visible, right? Screen is visible,
Yes,
right?
ma'am.
Okay, so I'm just scrolling it down. You can just check it. This plot I have done, then this type. It's not mandatory that this plot only you have to do. You can try and plot anything, but I just wanted to be more interactive. Like this kind of, like suppose I am putting this, like putting my cursor here, I am getting all of the information up here. So this is what I want. Clear? So this is all about the plots that I did. Clear, guys? Okay, I will try to, but if there is anything, like if it is not possible, so as discussed, like you will be able to access it through the like the recordings only. If possible, I will try to share it with you. Okay. Yeah. So any other question? So as I told, in case of any EDA project, like henceforth, when you'll be trying and going, try to use this interactive charts and try to include at least 14, 15 charts. And after the plot, try and include the insights that you have got. Okay. And for the presentation, one tip: don't just read from the collab and tell. Just try to put in whatever idea you are having. You can just put in. Just don't read the text that you have added in the collab. That is just a suggestion from my end. Okay. Clear? Everything clear, guys?
So, ma'am, will you share this data set?
Sorry, I'm not understanding Varsha.
Will you
Ma'am,
share
what?
this data?
Sorry, I'm not getting Varsha, what you're saying.
Ma'am, what about the people who haven't presented? We need to give two presentation at once next week.
Those who have not presented, since the number of people are huge, right, in the session. So at one part, we can't. You have all of you have submitted the project, right? So let
Yes,
me
ma'am.
just ask the management how they are going ahead with. So by next week, you will get the clarification, right? But it is mandatory to submit the project by the deadline. Okay.
Okay, ma'am. Thank
Okay,
you.
ma'am. Ma'am, are
Okay.
you sharing data set?
Data set, okay, like last time the project has been shared to you, this time also the similar way the project will be shared with you. Okay. So
Okay,
there
ma'am.
the data set details will be there. I guess most of the data set will be from the Kaggle itself. The source will be given, you have to just download it. Right?
Okay, ma'am.
Okay, okay, fine. So
Ma'am, will we get the
Hello,
recordings of the
ma'am,
previous
submitting.
session?
I'm
yeah,
project
yeah,
submitting
everything.
link.
No, it is not the link. It is the the mail ID has been given to you. There you have to submit the your project, like your collab file. Or one thing also you can do, you can just upload
Yeah,
your
ma'am.
project based on the project details. Like upload your project in the drive and give the access to use that drive folder and share the drive link also. Or you can for extra safety you can also share the collab file link. Okay, so it would be better if you can share the drive link, give access to the and share the drive link, like the
Ma'am,
drive folder, not the whole thing. Yeah, please tell.
will we get the recordings, ma'am, of the previous sessions?
Yeah, everything you'll be getting, but you need to just connect with the HR, because when and how the recordings will be given, that I am not sure of. I don't have the idea on that, like on how they are planning to give you the recordings. Okay, but rest of the things they will be able, like they are the accurate person to like answer this question of yours. Okay, you can just mail them. Definitely, they will revert back over your mail.
Okay, ma'am. Thank you.
Okay. And who are the new persons who have joined today or yesterday they have joined? Just raise their hands up. Okay. Only one. Okay. 3, 5, 5%. Okay. 5, 6% have joined late, right? Okay. Not an issue. See, we are going ahead based on that. Every week we are starting off with a new thing up, right? Based on every week, we have the like agenda ready with us. Okay, do remind me in the next session, next week only. In the first day only, I will be just sharing you or showing you what is the agenda per week, how we are moving it, so that you will be having the access that how we have what you have already, what things have already been cleared or already been done in the session and what is remaining. So you will be having the clear cut idea. Just any one of you just have to remind about showing the criteria or the agenda that is there based per week agenda. Okay. Any of you, Hasini, just remind me next week to show it. Okay.
Okay, ma'am.
Okay, so things will be more clear to you, and rest of the things, the recordings, they like it is supposed to be shared. The HR, like it does take some time, so the HR will be like letting you know and how and what format the recordings you will be getting the access of the recording.
Ma'am, do we
Fine,
get any certification also?
clear, guys? Yeah.
Ma'am,
After you are done with the internship, okay, there will be the certification will be given to you, but there is certain criteria like your attendance, your project evaluation, your like how you are communicating, your conversation, everything will be like taken into evaluation, and then only the certificate will be given. So as of now,
okay, ma'am.
and anything related to this, you can definitely ask the HR. You can mail them. They will definitely give you the details. Fine.
Okay, ma'am.
And I guess in the offer letter also, you have also got the details of the evaluation, how the things will be evaluated. Just keep a look to the offer letter that you have.
Ma'am, I
Okay.
haven't got yet.
Okay, then wait or just mail the HR. They will share. Okay.
Ma'am,
Fine.
I don't get any offer letter, ma'am.
Okay, this offer letter things I am not supposed to answer. This you have to mail them. They will like give it. They will just answer you on that. And I guess there are many people who have joined, so it is some time. Eventually, you will get all of the details, all of the official details you'll be getting. Fine. And stay
Ma'am,
active in the WhatsApp group. There, all of the details you'll be getting. Fine.
ma'am, I
Okay,
want
ma'am.
to know what type of internship is this.
Sorry. What type of internship means?
I, I don't have any idea. I applied a lot of internships. That's why
So it is AI ML based. You are sitting in the session. You have no idea what it is about.
I
First,
joined later, ma'am.
first go and check. I got it.
Okay.
You go and check what the details are. Then only you will be able to understand. Fine. I can
Okay.
think you have got at least a mail, right? Not if not the
Yes,
offer
ma'am.
letter, the mail. So you check the
Yes, ma'am.
mail. The details will be mentioned up there.
Yes, ma'am.
Okay. And for
Okay.
today, we are just wrapping up our session here. Eh, Sorry, Minakshi, you want to say something? Okay, fine.
So, ma'am,
We are just
when will
wrapping up
you
our
provide
session,
the
and
second
for
week
the
project?
new tomorrow only, tomorrow by tomorrow morning or today by night only, you will be getting. Since I am not sharing you the project, okay? So from there itself, like they are sharing you the details up, and I am just going ahead and I am basically not sharing you the project. They have the access with the WhatsApp group, so they are sharing the project over there, right? So they
Okay,
will be
ma'am. Okay.
sharing the project up whatever be the project by today or tomorrow. You need to work accordingly and submit it by Monday. And Monday will be the presentation session where you have to present your project. Fine? Clear, guys?
Okay, ma'am. Fine, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay,
Okay.
ma'am.
Then
Thank
we are
you.
just, thank you. We are just wrapping up our session here. we'll meet next week. Fine. You just continue and do your project accordingly, and accordingly we will be going ahead. Fine. Bye. Bye, guys. Bye bye.
Bye, ma'am.
Bye.
Okay, bye,
Bye
ma'am.
bye. Bye.